Hello, class. Today we'll be looking at a new topic titled Limiting Reagent or Reactants. So by the end of this lesson, you should be able to deduce balanced chemical equations from experimental reacting masses by calculating moles and determining the simplest whole number ratio. You should also be able to explain and identify limiting reagents in chemical reactions, perform calculations involving excess reactants, and identifying which reactant is in excess or which is limiting. You should also be able to apply the mole ratio concepts in your calculations of the amount of product formed from the reactions. Why are we studying limiting reactants? Why is this concept important to us as scientists? In many reactions involving two reactants, it is common for an excess of one of the reactants to be used to ensure that the other reactant is completely used up during the course of the reaction. This is often done if one of the reactants is readily available and cheap in terms of cost, and then the other one is expensive or rare. So let's say you have two reactants, A and B, reacting to give us C and D. It is expedient for us to have one of these reactants, A or B, to be in excess to ensure that the other reactant is completely used up during the course of the reaction. Take, for example, if we take A to be in excess, then B would be the limiting reagent. Okay, B will be the limiting reactant in this reaction. How do we determine which of the reactants should be in excess or which of the reactants should be the limiting reagent? In practical terms, what we do is ensure that the excess reagent is one that is readily available, one that is cheap. Take, for example, we want to burn fuel, for example, and then we have, let's say we have pentane, which is a fuel, plus oxygen, because we need oxygen for combustion to take place. All right, and then, of course, when we do this, we get carbon dioxide and water. So these are the reagents we get when we do that. So we get carbon dioxide and water in the process of this reaction. So water. So how do we determine which of these reagents will be in excess or the limiting reagent in this case? This is no brainer, very easy, because we know out of these two, one is readily available. One will require you spending your money and is not as available as the other. Oxygen is readily available in the atmosphere. So oxygen in this case must be in excess. Okay. And then the pentane, of course, which is the fuel, is the limiting reagent in this case. Okay. So in order for our fuel to burn excellently well, we need plenty of oxygen. We need the oxygen to be in excess so that the fuel can burn well. Okay, this is seen even when we burn things like wood during winter to heat the house. You know, when you burn this wood in plenty amounts of oxygen, you get more combustion, you get a brilliant flame, okay, compared to when you do so in limited amounts of oxygen. Take a good example of our gas stove that we use in the kitchen. You know, the gas stove is designed such a way to ensure that the amount of oxygen that is taken in during the combustion process is in excess. And that is why you always have a blue flame when you use the gas stove. Okay, so the gas is, in this case, is the limiting reagent or reactant, and then the oxygen is the excess reactant in that reaction. So fuels, like I said, are expensive and are also in limited supply. Okay, so the oxygen is readily available from air, so the oxygen should be in excess to ensure the fuel is burned completely. What happens if the oxygen is limited in supply? You get smoky flame, okay? Instead of the blue clear flame you get from your gas stove, you get smoky flame. And you're familiar with the fact that when you see a vehicle that is releasing smoky fumes from its exhaust, is an indication that the engine of that vehicle is no longer efficient. So what that simply means is that that vehicle will be consuming too much fuel than required. Reason being, it's not taking the right amount of oxygen to burn the fuel. So for us to burn fuel effectively and very well, we need oxygen in excess as the excess reactant. That will ensure the fuel is used up completely and not being wasted. So when one of the reactants is in excess, of course, the other will be the limiting reactant that is completely used up. Another way you can identify the limiting reactant is whenever the limiting reactant is used up, the reaction stops completely. I gave an example of your gas stove. Once the gas is used up, the flame goes off. When you don't have gas supply, no flame. And when you're driving your car and you run out of fuel, the car stops. Even with the presence of so much oxygen in the atmosphere, the car will still stop because the limiting reagent or reactant has been completely used up. So these are the two indications, okay, or indicators that shows what the limiting reagent in a particular reaction is. Okay, so let's pick an example because the limiting reactant determines the limiting reactant determines the amount of product you get because when it's used up, you don't get product anymore. When the pentane in this case is used up, when the pentane in this case is used up, you won't get carbon dioxide anymore because the reaction stops at that point. Okay, so let's pick one example and let's look at how we can apply this to a typical question, okay, in chemistry. All right, so we have uh, magnesium reacting with sulfuric acid, as you can see, okay, and now one of the reactants is in excess. So we have to calculate the mole of the product formed. How do we calculate the mole of the product formed? Remember what determines the amount of product formed is the limiting reactant. So for you to determine the amount of product formed in a reaction, you must identify what the limiting reactant is. Okay? Most students make the mistake of just using any of the reactants to determine the amount of product. That is wrong because in most cases, one may get the wrong answer. So the first thing to do is to identify which of these reactants is the limiting reactant. So that will inform us on what amount of product will be formed in this reaction. So let's start. Here we have magnesium reacting with sulfuric acid. The reaction here, as you can see, is the mole ratio is 1:1. So what this means is, going by the question, 5 moles of magnesium is reacted with 7 moles of sulfuric acid. I repeat, 5 moles of magnesium is, reacted with 7 moles of what? Sulfuric acid. So what this means is that 5 moles of magnesium was used in this reaction and 7 moles of sulfuric acid was also used. Now let's determine which of them is in excess. Remember, from this equation, we have 1 mole of magnesium requiring just 1 mole of sulfuric acid, which means 5 moles of magnesium should require 5 moles of acid. But in this case, in the question, 7 moles of sulfuric acid was used. Of course, that simply means your sulfuric acid is in excess by 2 moles, because ideally the amount of mole of sulfuric acid to be used is expected to be 5. But in this question, we're told it's 7. That already points to the direction of magnesium as the limiting reagent. Okay, so we will use this now to determine the amount of product formed. And that is by simply checking the ratio of magnesium to the product, of which is magnesium sulfate. Magnesium sulfate is also 1. Okay, so that means for each 1 mole of magnesium, we get 1 mole of magnesium sulfate, which simply implies if we have 5 moles of magnesium, we will produce 5 moles of magnesium sulfate. And that's simply is our answer for that question. If you're given questions that require masses, like the next question we have here about tungsten oxide reacting with hydrogen, as shown below to produce tungsten, you have 23.2 grams of tungsten oxide. The formula mass is given, and it's reacting with 20 grams of hydrogen. The formula mass of hydrogen too is given. To go about solving this question, all we need to do is simply get the mole, okay, get the mole of each reactant in this question. So we have our tungsten oxide plus 3 moles of hydrogen to give tungsten and water. Okay. Now we want to know the mass of tungsten formed. For us to get this, we need to know which of these two is the limiting reagent. Okay, and that is simple. In the question, we were given 23.2 grams of this. Divide that by the formula mass, which is 232, to get the mole. So the mole here is 0.1. For hydrogen, we have 20 gram, which will be 20 gram divided by formula mass, which is 2, and then we have 10 moles of hydrogen. So we check the mole ratio of tungsten oxide and hydrogen. That is 1:3, which means for every 1 mole of tungsten oxide, we'll require 3 moles of hydrogen. So in this case, that we have 23.2 gram used, which is equivalent to 0.1 mole, we should be expected to use only 0.3 gram, 0.3 moles of hydrogen, and not 10. So which means this is in excess. And then our limiting reagent is our tungsten oxide. And good thing, the mole ratio between the tungsten oxide and the tungsten is still 1:1, which means the mole of tungsten we have here will be 0.1. Okay, and then if we want to get the mass of tungsten, all we need to do is use our mole concept formula, which will be mole times the formula mass of tungsten, which is 184. And that gives us 18.4 gram of tungsten. So this simply means 23.2 gram of tungsten oxide, when reacted with hydrogen gas, will produce 18.4 gram of tungsten. At this point, I'll say thank you for watching, and do remember to subscribe to this channel.